Thanks for the introduction. Today, I'm going to be showing how we are exposing a GraphQL interface inside of a web application that we're building so that we don't need to grant AWS console access for exploring the AppSync APIs that we have. Just a quick introduction about me before we get into the talk. I, as mentioned at the beginning, am a senior developer advocate at a company called Canopy, based out of Metro Detroit. Since I have this role that's a little bit different called developer advocate, I just wanted to kind of maybe define a little bit what that means. So a big part of my role is responsible for building internal tooling to help support internal engineering teams. So we don't have any, open API or anything like that. So most of my work is focused on supporting our internal engineering teams and what they need. So just wanted to clear that up a little bit. I know the developer advocate title is a little bit different. In addition to my day job, I also teach outside of my normal work. I teach at a boot camp here in Detroit called Grand Circus, mostly teaching JavaScript courses there. I also have worked as a developer advocate at Shopify. So if you see my face, if you use any of the Shopify APIs, I'm sure you've seen me. I'm definitely on their site. And then prior to that, I worked at Ford Motor Company at a department called Ford Labs doing proof of concept web applications. So definitely some kind of wide-ranging software experience in my background. So now that we know a little bit about me, let me introduce the company that I work for called Canopy. So Canopy is on a mission to revolutionize vehicle security by bringing AI-powered detection and security features to truck and van customers. So in this slide here, you can see a little mock-up on the right-hand side of our camera. This sits within your truck cabin and faces out the back window over your truck bed. And then also there's a rendering of a screen within our mobile application. So what this device that we have offered does is it gives you live streaming capabilities. So within our mobile application, you can live stream at any time to check on your vehicle and the belongings within your truck bed. We also have a constantly running intrusion detection algorithm. So even if you're not live streaming, the device is able to monitor and also detect any suspicious activity either within your truck bed or around your vehicle. And you will be sent a notification to notify you immediately if there's anything that we determine as suspicious going on. We also have full OTA update capabilities, so we're able to push updates to both the device and obviously the mobile application to keep you up to date with the latest features that were developed. And for now, this is just a small feature set of what we have available. We actually only launched just last week. So if you are interested, definitely check us out. And yeah, stay tuned for more. We'll definitely have some new features and exciting things coming along. Okay, so now that we know a little bit about me and what we do at Canopy, I wanted to kind of define how we work at Canopy because I think that helps understand why we've built the demo that I'm going to show. So we are split up into 3 separate engineering teams. We have our device and hardware engineering team on one end. They're responsible for full hardware development and also any software on device. Within this team is also our AI and ML engineers who work on our theft detection algorithm. And then communicating from the device to the cloud is our platform team. That's actually where I currently sit, is within the platform. We develop the full API capabilities between device and cloud and front-end applications. So most of the AWS services and tools are used within the platform team. And then, of course, we have our front-end team, which uses our APIs to build our mobile applications for Android and iOS, as well as any marketing sites or our e-commerce site as well. So we have our kind of 3 separate tiers. And as I mentioned, I sit on the platform team. And since I am on the platform team, I'd like to share a little bit about how we have decided to build our platform. So as I mentioned quickly, the device communicates to our API that we call Canopy Services. We use the MQTT API and all of our devices are registered with AWS using IoT Core. This is how the device communicates up with our platform over MQTT. Within the platform, we also have an internal API that we call Haven. This API's responsibility is for evidence storage. So as our device detects and uploads telemetry data to our API via MQTT and Canopy services, Canopy services then filters evidence down into a separate API and storage area. Within Haven, we use KVS video streams. We also use S3 buckets to store thumbnail images and a few other pieces of data there, but the sole responsibility of Haven API is evidence storage for users. Now, back up to Canopy services and out through the front end, we do have a front end API in front of our Canopy services. This is where we use AppSync and expose a GraphiQL API so that our front end application can integrate back with the cloud easily using GraphQL. So hopefully that kind of high-level overview makes some sense. I now want to talk about why I'm giving the talk on exposing a GraphQL API. I just switching back one second, I did mention that Canopy Services is our kind of like brains of the application from a platform perspective. Most of our logic and business rules and things live there. But what we'll be focusing on today is exposing a GraphQL Explorer, so more kind of on the front end side of this diagram on the right. As we just heard in the talk before this, it is definitely difficult when you are on a team that is building both hardware and software at the same time. So as I mentioned, we have our device team. They are responsible for developing the full hardware as well as the software on device kind of sitting within that branch. But us on the platform and then front end team are also working as close to parallel as we can to develop our API and front end application. But this can be really challenging, especially giving our platform engineers and front-end engineers access to physical hardware as we're in active development of hardware as well was a real challenge for us. And since I am a developer advocate and my role is to make sure that the engineering teams have the tools that they need to kind of get their jobs done smoothly, one of the things that I built was a device and mobile application simulator. So very similar to the beginning topic, we have the ability to pull up a internal web application. This, again, it's an internal tool, so the branding here looks a little bit funny, but it's meant just for our internal engineers to go in and they can simulate what a hardware device would do without needing access to a physical device. So, for example, you could go into the device simulator and send a message to the MQTT topic to update a device's location using a GPS, fixed coordinate. That message flows along the same MQTT topics as the physical device hardware would, and then sets the data in the platform appropriately, just as a physical piece of hardware would. You're just doing it through a device simulator instead of an actual physical device. We also have there in the kind of second box an application simulator. Now, this was built because us on the platform team, being kind of more the in-between device and the front end, it was actually pretty challenging for us to do any kind of proof of concept or even story acceptance with our PMs on the team. It's not very interesting to look in CloudWatch logs to prove that messages are flowing through, just as much as it's not interesting to really look at, Postman responses to prove that the API that you built does actually work. So we started adding features into the app simulator so that we could see kind of the end-to-end flow in a mock-up, very rough, I'm definitely not a designer, very rough front end of what our app might look like using the data that we're building in the platform. And then as well as using this app simulator to kind of prove that our API is working in the way that we expect it to, and being able to test kind of end-to-end from device simulator through the platform and then to the front end as well. So We saw the need for the app simulator to be able to be updated quickly and work a little bit more independently of our front end team since they're focused on the mobile app itself and our e-commerce site and things like that. So that is one kind of challenge that we solved by building a device simulator and app simulator. We kind of eliminated the need for every engineer to have access to physical hardware. But as soon as we started building this app simulator, we started noticing that it is quite challenging to keep up with building some UI along with our API. So especially since we sit on the platform team and not the front end team. So we started kind of thinking that maybe exposing a GraphQL Explorer within the app simulator might help so that we could still prove that our data flows from the device simulator through to the platform, but only have to write the queries on the front end to prove that the data was there. And that for the front end team seemed like a good use case to fit into this device simulator or into this, simulation tool. Additionally, the front end team oftentimes has third-party developers and kind of contractors that come in and help build out some of the UI elements for our application and the front end site. So they were asking for access to our AWS console since that is where our AppSync API and GraphQL Explorer previously lived. But we on the platform team were trying to lock down some of our access to the AWS console rather than just granting everybody access to the GraphQL Explorer there. We thought that maybe we could build a GraphQL Explorer so that we only had to grant access to our simulation tool and not have to give access to everybody to the AWS console. So a little bit of separation there between who has access to AWS console and who can actually view and explore the GraphQL Explorer. One thing I will note too is we're definitely taking the self-documentation of GraphQL pretty seriously here on the platform team. So we don't have any true API documentation that shows this is what each query does. We just rely on the GraphQL schema to be enough information for the front end team to kind of use how they would like. So that's why we're relying so heavily on this GraphQL schema and why people were accessing AWS console directly to get to the AppSync schema itself. So yeah, definitely relying on the GraphQL self-documentation piece here. So hopefully that use case kind of makes sense and might be something that you want to explore on your team. I actually am going to do now a hands-on demo for how we built this. It's actually quite simple, but it's very useful for us. So just before we get into the actual code of this, I just want to mention that there are a couple things that I am not going to be set up. I'm just kind of assuming you have already preset. So basically, first off, just an AWS account in general. I'm using a kind of quarantine off environment in my AWS account. It has its own AppSync API setup, as well as a Cognito user pool with just one user in it. So I'm not going to be going through the steps of setting up any of these things in the demo. I'm just going to assume that it's kind of already set up. So yeah, just kind of a little caveat there. What we will use though is a AWS Amplify UI component package. Obviously, we're going to use AppSync API and we're going to authenticate in using a Cognito user pool. There are other authentication methods available other than Cognito, so just check the AWS docs there, but for the purposes of this demo, we'll use Cognito. And then to build the application itself, I'm going to be using Next.js. One note here is that how I have built this is taking advantage of Next.js client components. As I was putting these slides together, I realized that AWS has recently released some documentation for how to do server-side components for this as well. So yeah, definitely am going to look to update this demo with those, but how we're using this and how we'll be doing the demo today is taking advantage of client components only. And then at the end of this, we will, the slides will have the link to this GitHub repo, so no worries about following along exactly. So just before we jump in, I just wanted to mention that I already created a starter application. So just using the create next app command to get the latest next template. And then I installed these 4 packages. So you can see I am using this GraphQL npm package. This is a npm package released by the maintainers of GraphQL. It exposes that GraphQL Explorer that we saw a screenshot of, and it's actually super simple to use. So just taking advantage of this npm package. This GraphQL toolkit here just has the types. So I am using TypeScript, so I'm pulling the types from this GraphQL toolkit package. We are obviously using AWS Amplify to connect our client up to our AWS cloud instance. And then finally, we're using the UI React component library, as I mentioned. This just has a login front-end component for me that I can take advantage of, so I don't have to spend time in the demo, doing CSS and creating a form and that type of stuff. So just installed those packages for the purposes of this demo. So here is the next project that I've created. We'll go ahead and just get this started. Get some more room here too. Hopefully the screen size is okay. Cool. Go ahead and open up localhost. Cool. Now, as I mentioned, just using the starter template from Next. So this should look familiar if you're familiar with any of the Next starter template. It just comes with this landing screen here. So for this demo, the first thing I'm going to do is create a new route for the graphical explorer that we are going to create. Oops. So new folder. Okay. So now if I go to the graphical route, it is just going to have this page that I've created. There's no padding, so there's our word page here. The first thing we need to do at this route is authenticate in. So I am going to create a new component for authentication purposes. And what I am going to do within this component is use a authenticator. And this is coming from the AWS UI React library that I mentioned. So this authenticator component provides the ability to log in. It has all the UI elements that you need. So I actually am going to specify exactly how I would like to log in. So the login mechanism that we will use is going to be email. And let me update this closing. And then another option that I'm going to give is what we would like our users to sign up with. So the sign up attributes you can define. The ones that I would like to use are email, since we'll be logging in with email. I want the user to provide their name, and then I also want the user to provide their phone number. All of this stuff is configurable. You can check the documentation for the authenticator in the UI React package. In this case, I'm going to be logging in with email. In our app, we also give the option to log in with phone number. It's totally up to you and configurable here. I made this a separate component, and just for clarity's sake, you could definitely include this all within the same page, but I like to kind of separate this out. But because it is a separate component, I'm going to use it as a kind of wrapper component. So we'll go ahead and give it the ability to render, whoops, it's children. Okay, and then instead of off here, we'll simply just do children. And then to use this, what we're going to do is pretty simple. We'll just use it here. All right. So now I'm not going to re-render because we still have to configure. Yeah, we have to configure Cognito. It re-rendered automatically, so you see not the nicest message. But what this will do is we have our route at /graphical. This will render this page, which includes the child component for authentication. Once we have this connected up properly, it will have a login screen as well as a ability to sign up with those 3 attributes. So just maybe to get this error out of here, as I mentioned, we're going to be using use client. So we'll mark that parent component as use client. And then from here, what we need to do is actually point this authenticator to our Cognito instance. So I am going to create a new file for configuration. And within this configuration, I am just going to use the Cognito information that I have already set up. As I mentioned at the beginning, this is preset. So this amplify config object is using this amplify configuration here. So this connects our client, being this web application, up to our AWS instance. We will be using the Cognito that I've already set up. So that's just the connection details there. And then in order to actually configure this, the last thing that I need to do is call amplify configure, as we saw in that document. Oops. And then we are going to use our amplify config that we just defined. And just missing an import here from AWS Amplify. Give this a second to re-render. Here we go. So you can see that I got dropped right to this hello world, and this is because probably I have some cache. So let's go ahead and look in a private browser. So localhost 3000 and then the graphical route. You see that I get something that maybe looks like a login screen. It's not the prettiest, but luckily for us, we can just use the CSS defined from that AWS React library as well. So as long as I include this style here in our layout page, this definitely looks more like a login page that I would expect. You can see that I'm being prompted to log in with my email. And if I look at the Create Account tab, based on the sign up attributes where I'm prompted to sign up with email, name, and phone number. As I said, I already have this configured, so I am just going to log in. This automatically prompts you to verify. This is actually not a real email address, so I'm just going to skip. You can disable that skip, of course, but just for the purposes of this demo, we'll leave it. And there, again, you can see that I did get to my Hello World route. So through the authentication and then back to this page, which prints out Hello World. Cool. So super simple to configure, amplify, to connect to a Cognito user pool. The next step from here is actually connecting to our AWS AppSync account. So back to our configuration object, this object is going to hold all of the AWS configuration details. I'll add an endpoint for the AppSync API. So this API object has a endpoint object within it. This name is important. It is how we're going to key the fetcher in a second. So just make note that this name graphical here is how we'll reference this in the future. The endpoint defined here, I'm just using the AppSync API that's defined by AppSync. For our actual simulation tool at Canopy, we do use our nicely defined Route 53 domain. But yeah, for the purposes of this demo, it works just fine to use the AppSync API, but you can use the Band URL as well. It will work the same. So now our configuration object has access or knows where to go for our AppSync API. Let us go ahead and try and connect a graphical explorer. So within the authentication wrapper, instead of printing out "Hello World," what we would like to return is a graphical interface. You see this graphical came from that graphical package. And then the error message here is that it is required to have a fetcher inside this graphical component. So this fetcher is the kind of middleware between what you need to do from what the Graphical Explorer is calling back with, and then anything that you need to access your actual API. So inside this fetcher, we are going to define our own fetcher. And this comes from that graphical toolkit type there. Pass this in. We have some GraphQL parameters that come through. And what we need to do here is we need to attach our fetcher to the API that we have just defined in that configuration object. So we will use this API object from AWS Amplify. As we know, GraphQL calls are just posts. So we will make a post to that graphical API that we have defined. This is where that name comes in. So here, this is the name that matches the configuration object here. We're not going to send in any extra configuration details here, but we do need to pass in the body. So the body, we're just going to directly pass through from these graphical params. Missing an import here. Cool. And again, on the screen, you can see this probably looks like something that might be a graphical explorer, but it's pretty ugly. So let us go ahead and add the CSS. Again, this graphical package is nice and gives us a CSS to import directly, so we don't have to waste time. And you can see here, now this is a graphical explorer that looks probably pretty similar or familiar, but you can see I am getting an error with the status code 401. Now, this is because although we have our authentication set up in this parent component here, we are not doing anything within this fetcher to attach any authentication method itself. So it is just making a post request to that endpoint that we have defined, but we still need yet to attach our authentication header to identify ourselves for this endpoint. One option for doing this is you could add in a header parameter here within this post call, but I actually think it's a little bit cleaner to add a custom header within this endpoint configuration object. So that's what I am going to do here. And just for the sake of time, I will just drop this in. So what we're going to do here is add a custom header, which is the response of this function. The header includes the authentication mode of Amazon Cognito user pools. We also need to use our authentication helper from the AWS Amplify library. We'll pull the JWT token off the current session. And I saved, so we got a hot reload, and you can see that the error message here is now cleared because now we're attaching our authorization header. And if I go ahead and take a look at the documentation, you can see that this is actually now filled out with our schema details of our API. So as I said, this is just a test environment. I don't actually have any test data here, but because we have the queries, mutations, and subscriptions defined, this means we're making it through authentication, and theoretically from here, you could start testing out the API. Just one thing to mention too is we do take advantage of subscriptions in our API, but this Graphical Explorer is not set up to use WebSockets, so it won't be able to test subscriptions that easily. But That is pretty much the demo. As I mentioned, it's pretty simple and straightforward, I found once I, connected all the pieces together. But this has been an awesome lifesaver for us on the Canopy team. So that is all I have. If there's any questions, please feel free.
Yeah, as I mentioned, Megan, it was a great presentation. Giving live demo is always challenging. So glad that it all works out and we learned a lot from this presentation. So one question I'm having is the between the GraphQL and the normal API. So what is the difference and how one should perceive?
Yeah, so on the platform team, as I mentioned, we have actually three separate APIs. Our Canopy Services API is kind of the brains, where most of the business logic is. Then we have our Haven API for evidence storage simply. And then we also have our front-end API, GraphQL. I find in developing these APIs, the GraphQL one is actually one of the simpler ones. It makes it super easy because we have, our Dynamo resolvers, kind of pretty simple to just connect. We also have just a few like lambdas that do special things, but for the most part, it's a pretty clear read from Canopy services to respond to the GraphQL API. It's more the Canopy Services API that definitely has a lot of the challenges. That's where we use most of the different AWS tools. We use EventBridge quite a lot in there, lots of Lambdas, definitely a lot more going on than in Canopy Services rather than our GraphQL API.
That's great. Yeah, thank you. And between the GraphQL with the AppSync, like how easy it was?
Yeah, so the AppSync Explorer is very simple to use. It's just a matter of we didn't want to give access to AWS Console to anybody that needed to see that Explorer. So it's pretty easy if you're familiar with AppSync Graphical Explorer that's built in. It should be pretty much the same between that and the GraphQL Explorer I showed.